Ladies and gentlemen, welcome to Vector Virtual Week 2020. My name is Tariq Javed, and today's presentation is about synchronous data logging and replay on Ethernet. Here, I'll be discussing two very interesting use cases where customers are trying to replay or inject the captured log data or simulated data into their test setup. So, if you're working on something similar, are planning to do something similar in the near future, then I would like to invite you to have a discussion with us on this topic. Virtual testing is becoming indispensable for ADAS feature validation. Let's imagine ADAS system under test and then ADAS hill, SIL, or mill test bench where we have to take into account or take care of a number of different inputs. We have to take care of the sensor simulation of LiDAR, radar, ultrasonics. We have to think of how you're going to inject the video data, how you're going to simulate the GPS, as well as simulating the V2X data. Other important thing we have to take care of is data bus simulation, providing the remaining network simulation. Being able to simulate the ECUs, which would then interact with the ADAS ECU and then complete the system. Then we are left with doing the environment simulation. So here, a number of things will be taken care of. For example, simulating the vehicle dynamics, being able to simulate the track information, as well as simulating the traffic, as well as getting some inputs from the driver's point of view. Now, all of these inputs coming from different sources, either the data is simulated or replayed after the data was logged. But the other important thing we have to take care of is synchronizing all of these different inputs from different sources. Now, let's have a look at what's available out of the box from the vector's point of view. So if we take example of CAN and FlexRay, first of all, we have replay block available. Replay block, those who are familiar with the CAN and Canalizer will remember that gives you the option to replay the messages on the bus. From the CAN point of view, it's a simple message replay. From the FlexRay point of view, you have to select one ECU and then the data related to that ECU would be replayed. Other option in terms of the data replay is the signal-based replay. So here you would select a signal from the log file and that signal would be then linked to the remaining bus simulation and then the data would be replayed and transmitted within the remaining bus simulation. If it comes to the Ethernet, then the only option available is the replay block. Now, let's have a look at the some of the challenges one would face working in this domain. First of all, from the replay point of view, simple option available is the replay block. But that replay is done on the MAC layer, on the layer 2. So you wouldn't have any control over how and when you would be transmitting this data. So you wouldn't have control into the embedded protocols within this frame as well as the actual data. Now, if the ECU and systems are utilizing the SECO-C-based communication, then the frame-based replay is completely useless. It wouldn't have any meaning. Same goes for the TLS or IPsec protocol. These are the security protocols, of course. Now, we can also consider this TCP packet replay, but the TCP link wouldn't support the simple replay as well because the sequence number would go out of sync very quickly. Then it comes to the service-based communication. Now, With the Ethernet, we'll be utilizing more and more service-based communication, for example, some IP. So some IP, we have to take care of service discovery. And as we know, within the service discovery, you've got the server, you've got the client. Server would offer the service, client would subscribe it, but then there is a timing window where the client has to subscribe to the service. And then other challenge, of course, is that the data, if the data becomes available, then we have to be able to control this data. We have to figure out how you're going to copy this data into the signals, which would then be packaged into the PDUs, and then PDUs into the frames, and then those frames will be transmitted. Other important thing we have to think of is, what is our main goal here? Are we interested in purely the data replay? Are we application focused? Are we looking at the communication layer or physical layer? But here, our focus should be purely the application layer. And then last but not least is the data description. A credible data description. For example, if you're discussing the Ethernet, then it's a good ARXML file. As well as we have to take into account the OEM specific extension for building the remaining bus simulation. So as you are copying the data, signal data, we have to take into account those extensions as well. Now, on to the first use case from the first customer. This is their setup. ECU has got the inputs coming in from the number of different cameras, and then the output is being displayed on the TFT screen. Now, in their current setup, they are capturing this video data over the LVDS into the NI setup, as well as they're capturing the remaining Ethernet, some IP communication over the 100 base T1 into the NI setup. And they are generating two different log files, PCAP as well as MF4. MF4 is the requirement from their customer, of course, but as I understand, PCAP doesn't handle the high bandwidth data, as well as it doesn't carry all the header information which are useful or required for doing the data replay. Now, over to how this data is being replayed currently by these customers. So first of all, they decided that they would replay the video data from the initial instrument setup, whereas they would utilize Canoe and the rest of the vector setup to do the to replay the Ethernet data, using the remaining bus simulation and, of course, utilizing the some IP injection layer. Now, first task was deciding how the data would be imported within the Canoe setup. So they settled in for, first of all, converting the log data from PCAP and MF4 into the CSV, and then they selected number of signals which are required to carry out or to verify certain functions. Those then signals would be copied into the CAPL, into the float array. And then the last thing left was providing a trigger as to when this data should be copied over to the signals for the transmission. So they were getting, since they were getting the trigger requests anyway from the ECU into the NI setup, they decided that they would utilize the digital I/O from the VN5640. So the NI setup would set the this digital input to high, which would be then read within the CAPL setup, and then this would set number of different timers, which would ultimately then start copying the different data sets into the signals. Signals are then handed over to the network simulation, which are then packaged, of course, into the PDUs by the SumRP injection layer for the normal data transmission. Now, for this triggering, they considered other methods as well. For example, they considered FTX, they considered shared variables, they also considered the ActiveX, but they settled for using the IO trigger. That was giving them about 1 millisecond resolution, which they thought it was sufficient for their use case. Now, moving forward, after several discussion with this customer, and that's the point we started to get involved with the project more and more, it was decided that they should use ISO 15888 for synchronization purposes. Now, what I'm going to show you is the proof of concept, and this is something that this customer is working on as we speak. Now, in this setup, there is a clear split. Even the data logging is done on two separate systems. So, for example, here, the video data, the camera is obviously connected to the ECU over the LVDS, and that video data is captured by the NI setup, whereas the remaining Ethernet communication, some IP or do IP, is being captured by the vector setup. And here it is the CANU. And now the two setups, of course, are synchronized over the GPTP link, and thus producing two separate log files. The log file on the NI setup carrying the video data, and log file on the vector side, of course, carrying some IP and the rest of the Ethernet data. But two log files are fully synchronized. Now, when we would go into the replay part of this is the again the outlook. That's how it's going to look like. So the video log data would be replayed again using the NI modules from the NI chassis, whereas the rest of the Ethernet, especially some IP communication, would be done using the vector and CANU setup, using the CANU rest of the bus simulation, and especially some IP injection layer within the simulation setup. Now, here the log data would be then imported into the CANU setup. There will be some type of signal extraction done to be able to copy that data over to the signals, which would then be passed over to the network simulation. Now, keeping in mind, this signal extraction currently is planned that this will be done within the CAPL. So it will be manually coded within the CAPL file. Because all the use cases, as I mentioned previously, all the use cases we have seen, the use cases are unique. But if we see similarities in the requirements across the number of different use cases, then we can come up, of course, a way of automating this process, but this is remain to be seen. But then, of course, when it comes to replay, of course, this sync GPTP link would again be utilized, and now we're going to see how this data would be replayed. Now, let's assume that this is some IP log data coming from, for example, the vector. This is the data stream within the log file. Then another setup has got the video log data, and this is the data stream. Here, the red dots are the PTP sync flags. So both the files are completely synchronized. And now when it comes to the replay, we'll have a GPTP master and there'll be a GPTP slave. Master would give a flag let's say 200 millisecond to the slave that we will be starting the replay in 200 millisecond. And then this would be the current time. This is their trigger to start the replay. And then both sides would start replaying the data as expected synchronously on the bus. Now, moving on to the customer B, second customer, and this is their use case. So they are utilizing Nature Instrument setup to do the plant simulation, as well as simulating the number of different sensors, as well as running the MATLAB Simulink models on the NI setup. Whereas they would use the vector setup, CANoe, to do the FlexRay as well as Ethernet network simulation. Now, the data for the FlexRay as well as the Ethernet simulation, signal data would be coming from the MATLAB Simulink models, which is within the NI platform. That data would be exchanged between Veristan and CANoe over the shared variables CVI runtime library, which is embedded within the CANoe. But then, of course, there's a requirement for synchronization to give the trigger when to copy this data over. And that's, again, the GPTP synchronization would be utilized across the two different setups. Another use case is, and this is just another variant of similar use case, where instead of the NI platform, here their customer is utilizing the DSpace platform. And Simulink data is exchanged here between the controllers and CANoe over SIL library or FDX. That's how the data would be exchanged. The data would then be ready to be copied for the Ethernet network simulation. Again, when to copy this data, the GPTP synchronization would be utilized here. Okay, just to summarize what we've discussed in this short session, we established that the synchronization across different input is very important for validation and verification of the ADAS features. Now here I've discussed a couple of different use cases, and almost every use case is different, thus requiring individual solutions. Other important thing, of course, is that we have to keep in mind that our focus here is the application layer. Simply the data is copied whether from log data or from the simulation, and then packaged, passed over to the simulation setup, where it is packaged into the next available PDU, and the PDU is then packaged into the frame and then transmitted on the physical layer. Okay, this is the end of my presentation. Thank you very much for your attention. Bye.